When you're doing data extraction for a scoping review or a systematic review, the danger isn't that AI gives you nothing. The danger is that it gives you something that looks completely right until you check. So when NotebookLM released a feature specifically designed for structured data extraction, I wanted to test it properly on my reviewed papers. And in this video, I'm going to show you exactly what happened. Hi there, I'm Dr. Kenny Wong and I run a business helping international students with their master's and PhD research. As an academic at 2 UK universities, I've seen countless of students struggling at the data extraction stage, and this is what this video is about. I've tested other AI tools for this before and found accuracy issues, which is exactly why I wanted to put this one through a proper test. Now, I'll be honest with you, NotebookLM was not a tool that I took seriously at first. It didn't really fit what I needed for structured research work, so I very quickly moved on. In December 2025, Google added a feature to NotebookLM called data tables. You can upload your source documents, in this case academic papers, write a prompt describing what information you want to extract, and NotebookLM generates a structured table pulling that information directly from the uploaded sources. This sounds exactly what scoping review researchers need. So I decided to test it on my own papers. I'm going to walk you through exactly what I did, what NotebookLM produced, and whether I would trust it for real submissions. Let's get started. Let me set the benchmark clearly because this is what I'm looking out for when I'm interpreting the results. When we conduct data extraction in a scoping review, it is not merely about summarization. We are pulling precise, structured information across potentially dozens of papers. Sample sizes, methodologies, population characteristics, key findings, the errors that matter most may not be very obvious from the outset. A misclassified methodology, a finding attributed to the wrong subgroup, a sample size that is slightly off, those do not get caught unless you go back to the source, and this is what I'm testing for. When you open NotebookLM, the first thing you want to do is to create a new notebook. I uploaded all 39 papers as sources. You simply drag and drop your PDF and the tool indexes them automatically. Now, for this video, we are specifically interested in Studio on the right over here, specifically data tables. However, clicking on data table would generate something that's incredibly generic. You'll want to click on this arrow over here to prompt AI what you want it to extract specifically. Input your extraction prompt here, and this is where your skills as a researcher matter. Because NotebookLM will only extract what you are asking for. The quality of your prompt shapes the quality of the table. This is the prompt that I've used. I first asked her to extract the data that I want. Note that I'm very specific in my wording. From experience and from research literature, your prompts need to be very specific to reduce errors. I also included additional instructions to create a row for each of the uploaded source and to include all sources. From my prior experience of testing it, I realized that it will omit sources or combine them if they're too similar. For organization purposes, I instructed it to list by alphabetical order of the first author's last name. There are three things that I'm looking out for: whether the table was complete, whether the basic bibliographic data was accurate, and whether the tool can handle the kind of nuance that typically trips AI tools up. Starting with the completeness of the tool, we have 39 rows as instructed. All 9 columns are clearly presented and the papers have been ordered alphabetically also as instructed. I also didn't specify a format for the author column, but Notebook defaulted to last name only, which is exactly what I needed for citation purposes later. The titles and the years also appear quite accurate. I cross-checked these against my Zotero entries, so the structure held up, but the columns on the left are the easy part. The next few columns is where the test really begins. So let's have a look at the first paper by Al-Adal et al. 2022. The types of data collected are correctly identified as per the paper, and NotebookLM was specific enough to note that the tweets in this study were German specifically. That level of detail matters. A generic extraction would have simply just said tweets. The number of data points collected and the number that was actually analyzed were also correctly extracted. This is worth pausing on because in this field, studies routinely collect millions of data points but analyze only a fraction of them. These are two distinct numbers, and NotebookLM identified them separately and presented them as requested in my prompt earlier. Finally, the explanation of how AI was used. The model that was applied and the stated justifications were all accurate and consistent with the paper. Across the remaining papers, the pattern held. Titles, years, author names were all consistently accurate, and in the columns that require genuine comprehension, study designs, AI models use, justification, NotebookLM was extracting the right information from the right papers. For a first pass across 39 sources, this is quite meaningful as a result. But this is not the finished extraction. This is where we need to start talking about the problems that I'm noticing. I found 4 specific problems. The first is methodological misidentification. If you look at Al Adal's paper, NotebookLM entry states sequential explanatory mixed methods with a thematic analysis, but mixed methods refers to the study design, not the analysis process. It was able to identify RTAP as the process, though the actual type of thematic analysis I requested for is unclear. This is precisely the type of plausible error that I described at the start of the video. The output looks credible, and if you're not familiar with these methodological frameworks, or if you have not read the papers yet, you wouldn't have been able to catch something like that. The second problem is a citation error, but this might potentially be a prompt issue, or perhaps it's the way NotebookLM is built as well. I asked NotebookLM to include citations for the thematic analysis used in the table. What it has done instead is to cite the exact paper that it is actually reviewing. So Al Adal appears as the source for its own extracted data, which tells me nothing that I do not already know. Now, this may be a result of how I phrased the prompt, but here is what matters. The error has propagated across every single entry in the table. So one ambiguous instruction and now every row is being affected. The third problem is insufficient depth of synthesis. The AI usage column for Al Adal is technically in the right direction. However, it's a bit too shallow to be useful when I'm writing. When I'm synthesizing across 39 papers, I need enough detail to juxtapose the methodologies side by side. What I have here raises more question than answers. For reference, this is the level of detail I included in my own paper, and this is the standard I need extracted data to meet. The fourth problem, and the most significant one for rigorous review workflow, is the absence of an audit trail. When NotebookLM generates a data table, it doesn't tell you where in the paper it has found that information or how it arrived at that output. Verification is therefore extremely difficult based on this table alone. Compare that to Elicit AI, which provides explicit quotations from the source paper alongside each extraction and shows you the reasoning behind the output. That transparency is what makes verification possible. Without it, you are trusting the tool, and as we have seen, that trust is not always warranted. It also means that there's a lot of work that you need to do if you're going to go locate where AI is drawing these conclusions in the extracted table. The truth is, NotebookLM can handle basic data extraction for straightforward fields like titles, years, author names that is reliable. But the moment extraction requires some level of interpretation of the methodology, the accuracy starts to become a little bit more questionable. And because it provides no audit trail, identifying those errors manually is going to take a bit more time, which then makes me think, is it suitable anymore? My use case here is very demanding. I'm asking you to extract data that requires a meaningful level of interpretive judgment, and that may be more than what we can currently expect of any AI tool, but that is why it needs to be tested at this level. I generally get the sense that NotebookLM may not be developed with researchers in mind, and so while it may be useful for writing assignments or writing blog articles, for example, it may potentially cause problems for researchers instead. As always, I would never recommend that you use any AI tool blindly. It can make mistakes, and in a systematic review or scoping review, especially if you're thinking of publication, an uncaught mistake can derail the entire study. Verify everything with manual extraction as well. The hunt for the best AI research assistant is still very much on. What I would think would be genuinely useful is a direct comparison between NotebookLM and Elicit AI. The same 39 papers, same prompts, side by side. Elicit AI has a comparable extraction function, and that kind of controlled comparison would actually tell us something a bit more definitive. If you would like me to run that test, let me know in the comments below. And if you've not seen my previous video on how I use Elicit AI as a second reviewer in my data extraction process, that is definitely worth watching next. I'll put the link on the screen right now, and I'll see you in the next video. Goodbye!